Okay, so example 2, after slow start. Again, this is kind of impractical, but I just want to give you an idea of what happens when we lose packets. Every time we slow start, 10th packet is lost to fading. What's more is I'm going to violate the indirect TCP separation between the wired and the wireless sides, and I'm going to say packet loss on the wireless link equals no acknowledgement to source. And by doing that, again, this is the opposite of what indirect TCP wants you to do. But what I'm going to do is I'm going to show you the importance of indirect TCP and why this causes such an enormous problem. Why this kind of thing, this lack of isolation between the two sides, causes a big problem. Okay. Segments. 9. So remember, no ACK to source means window lost. All the segments in that window get dropped. Okay. So once again, we start with a very large congestion threshold. We start off with a window size of 1. Here's my K. Start out with a window size of 1, 2, 4. By the way, how many packets have we had in total here? 1,
7.
3, 7. We're in slow start, so we know the 10th packet is going to get lost. Okay, 1, 2, 4. My congestion threshold is infinite. What's the next window size? 8. Which 5 go here and 3 go to the buffer, so that's perfectly fine. My buffer, we're still going with K equals 5 and equals 8. However, my number of packets transmitted is now 15. And I know the 10th packet got lost. Because the 10th packet got lost, this acknowledgement is lost, and I lose that entire window. Okay, I lost that window. I start over in slow start. By the way, what's my new threshold? 4. Start over in slow start. 1, 2, 4. What's my next window size? 5, because my threshold is 4. How many packets have I sent? 1, 2, 3, 7, 12. So the 10th packet after slow start occurs in here. So this guy is lost. What's my new window size, or threshold? Let's go with 3. So actually don't know. I think it's round, but I'm not sure if it's round or 4. So let's say round. So 3. Now I have 1, 2, 3, 4. How many packets am I sending? 1, 3, 6, 10. So in fact, the 10th packet occurs in here, and that's what it goes. And now my window size is what? 2. Again, I have 1, 2, 3, 4, 10th packet here, that's wiped out. So this is now the steady state behavior.
So we set the congestion window to the threshold.
The congestion window, when we start at slow start, yeah, let's distinguish between the congestion window and congestion threshold. We start again at slow start, the congestion window is always 1. Congestion threshold is always half of whatever the last window size is.
Is there a case where you do the congestion window to the threshold? That's when you go above the threshold. So if you're going 1, 2, 4, then 8, threshold is 5, then.
Oh, I see what you're saying. So, yeah, if the threshold is 5, and we go 1, 2, 4, 8, 8 occurs is 5, so you just go to the threshold. Again, if the threshold is 6, you would go 1, 2, 4, 6. 1, 2, 4, 7. If the threshold is 7. Okay, anyway. How many segments got through? 6. How many round trip times? 4. Capacity of this link is now 1.5 segments.
Probably got question like why are those packets being lost?
So what we're assuming is that they're being lost to fading. So there's a sudden deep fade. So if you're walking along with your
so often there's a deep fade.
That's right. So I mean.
Okay.
This is totally unrealistic that exactly the 10th packet would get zapped. So what you would do in reality, or there would be some random relationship, but I just wanted to show you what happens. I wanted something that I could do up here without being terribly arbitrary. So ordinarily, you could interpret this to mean every the probability of packet loss is 10%, something like that. So you have your mobile handset, you're walking along, you pass behind. Pass into the shadow of a building, you lose that one packet, but then you emerge and you have a linking. Okay, so this is kind of a bummer. We go from 4.125 with no packet losses to 1.5, and how many packets did we actually lose? We only lost 1, 2, 3, 4 packets. So that seems kind of unreasonable. So let's do the same thing again, except let's turn indirect TCP on. So let's remember my first example was no packet losses at all. Now I'm showing you what happens with packet losses when you're not using indirect TCP. Now I'm going to keep these packet losses, but I'm going to show you what happens in indirect TCP.